All right, today we are going to start looking at section 5.3. We're going to do part of it today. And this is going to be looking at our trig graphs. So specifically today, we're going to be looking at our sine and our cosine graphs. So the graph is going to give us a better idea of the behavior. Remember, we talked about ending behavior first semester. What happens is we go to negative infinity or positive infinity in the x. Where's our y going? So this is going to help us look at that. So we're going to look at graphing the sine and cosine functions and then look at some transformations, just like we did transformations in the first semester. So to help us graph the sine and cosine functions, we need to first realize that they repeat their values in a regular fashion. So think about the unit circle and our values after we make one complete loop at 2 pi, then they start and their values are the same again. So when we're looking at our sine of t plus n 2n pi, every time I get to 2 pi, the same pattern is going to start over again. Same thing for cosine. So when we do this, the sine and cosine functions are periodic according to the following definition. So a function f is periodic if there is a positive number p such that f of t plus p equals f of t for every t. Just meaning that once you get to 2 pi on a graph, your graph is going to start and look exactly the same again. So it's graphing the same thing every 0 to 2 pi to 4 pi, it will look the same every single time. Okay, so the least such positive number is the period of f. We'll learn how to find that. If f has a period p, then the graph of f on any interval p is called one complete period, meaning the graph completes one complete what it would look like, the curves and everything in it. So the periodic properties of sine and cosine that we have here, the function sine and cosine are going to have period of 2 pi. It's important to remember that. So sine of t plus 2 pi is the same as sine of t, and cosine t plus 2 pi is the same as cosine of t, because think about if you're right here, and once you make it all the way around, you're starting over again with the same values. So sine and cosine functions repeat values in the interval length of 2 pi when we're sketching their graphs. So if we can sketch just one period, then it's just going to repeat itself over and over, and we can figure out what's going to happen. So we're going to sketch the sine and cosine between 0 and 2 pi, and then I'm also going to do some that are longer. We can make a table of values and use the points to draw the graph. So on your notes right now, you have t and you have sine t, cosine t, and then a bunch of values between 0 and 2 pi. So if you need more practice, it's always good. For example, if you look at your first one, you have t is 0. So at 0, sine is 0, cosine is 1. Then you have pi over 6. Your sine is 1/2, your cosine is radical 3 over 2. So those are just your points. So you can fill in that table, pause the video, fill that table in, see if you get it right, because then I'm going to show you the answers here in just a second, which are these. So what we're going to do is we need to graph all of these on our number line to figure out what our graph is going to look like. So you have a graph down there. I'm going to start with sine. So the first one we're going to graph is sine of t, and what does that look like? So my graphs are going to be complete, so you're probably going to have to pause, draw on your graph, and listen and do some things as we go. So we're going to use those, and again, I'm going to start with the graph of sine. So what you're going to do is you're going to plot all those points. So think about it. You have t is 0, that's kind of like our x value, and sine of t is 0. So notice right here I have that point 0, 0. Okay, I might change my ink color here to something different, so we'll use green. So we have the point 0, 0. Then on our table we have pi over 6, 1/2. Well, pi over 6 is labeled pi over 6 up 1/2. On yours you have 4 little lines like over on your y-axis. I would make, all the way up 1, label where your 1 is going to be. Then you have for pi over 3, it's radical 2 over 2, 1. For pi over 3, sorry. At pi over 3, it's radical 3 over 2, so not quite to 1. At pi over 2, you're up here at 1. So you could easily just graph 0, 0, pi over 6, 1/2. Skip those. We are back down here at 1/2, and then at pi, we're at 0 again. Then notice now we're just going to go down. 7 pi over 6, I'm at negative 1/2. 3 pi over 2, negative 1. Again, draw it in. And that's one complete rotation. Sketching in, notice it's a curve. They should not be straight lines. So this is one complete period, 0 to 2 pi of our graph. Okay, So now what that means, as it's a periodic function, is as we go on, if we were to do this and continue on with this graph, it's just going to do that same thing, and it's just going to continue looking like that. So for example, if I go out to 4 pi, you can see here on my next graph, we can still graph, if you're graphing this, graph your 0, 0, pi over 2, 1, get the really important points enough that you can sketch it at 2 pi, and then it does the same thing over again, right? And then it could also do the same thing going in the negative direction because it's just going to go down, up, down. Notice it's the same thing. It's a sine wave or a sine curve. Continues and keeps on going. Okay, I'm going to recommend, and I know I have this later on in the notes too, but we also need to be able to notice what this looks like with our calculator. So in your calculator, you can graph this, do y equals sine of x. Okay, make sure you're in radians. You must be in radians. You should be, but if you're not, if you've changed it since the last time we did anything, make sure you're in radians. So put your calculator, do y equals sine x, and then graph it, and then hit zoom trig. So go to the zoom button, go down to zoom trig, and you should get a graph that looks similar. You can see it continuing over and over, just so you can kind of see what it looks like in your calculator. Okay, so take a moment to do that. Then we're going to look at the graph of sine of, or of cosine of t. So we're going to do the same thing. Take that table and we're going to graph it. You're going to have to notice the difference in between the sine and cosine graphs. Our sine graph starts at 0, 0, goes up, and then moves. Our cosine graph, if we look at it at 0, is up here at 1, so it starts at 0, 1. Then at pi over 6, we're at radical 3 over 2. At pi over 3, 1/2. Pi over 2, 0. Then you can just keep plotting your points. Goes down. At pi, we're down at -1. Then it goes back up again at 3 pi over 2. I'm at 0 again until I get to 2 pi, which is 1. So this one, that's one complete cycle, one period of our cosine t. So then if you were to go out to 4p again, or 4 pi again, you can see one period was our 0 to 2 pi that we graphed over there. Then from here it just starts again, goes down, just continues in both directions. Okay, so make sure that you know, again, so here, make sure you see what your calculator, you could do y equals cosine x. Make sure you're in radians, you should be if you just did the sine. Do your zoom trig and you should get a graph that looks similar to that. Okay, so that will help us with our graphing. So some more things about graphing. We already did all that. The graph of the sine function is symmetric with respect to the origin, so it's an odd function. Okay, keep that in mind. You need to know that the sine is odd. The cosine is even. It's symmetric with respect to the y-axis. So if you were to like fold your graph at the y-axis, it's the same on both sides. Okay, we already did the use your calculator thing, so don't worry about that. So now we're going to look at some transformations. We're going to take those two, what we call the parent functions. Just like we did in semester 1, we moved things left and right, up and down, we reflected them. We're going to do the same thing with these two graphs. Okay, so we're just going to start by looking at it. We want to sketch the graphs of, we have two different ones, A and B. I'm just going to start with A right here, 2 plus cosine x. Well, remember, if I'm adding 2 on the outside of the function, that just means that the function is going up 2. So you're just going to you're going to go up 2, shifted up 2 units. You're going to take that cosine function we just graphed, which is this blue one down here, and you're just going to move it. Instead of starting at 0, 1, you're going to go up 2, and it's going to be up here at 0, 3. So everything is just going to be moved up 2 units. I was down here at -1. I move up. I'm at 1 now because I went up 2 units. And then it's just the same curve. So think about this middle of the graph where it was at 0, has moved up 2 units at 2 right here, and then you're drawing the graph again. Okay, again, you might need to take some time and pause it. So now what if I want negative cosine x? Well, negative on the outside right here, this negative on the outside, means that we're reflecting the graph on the x-axis. Negative on the outside is reflecting the x-axis. So the y, or the blue right here, was my first graph. That's the one we graphed at the beginning. All we're doing is reflecting it, which means if it was positive, it goes to negative. 0 would stay. Negative goes to positive. so forth, and you have the graph again. Remember, these graphs can continue on forever. Usually you'll be asked to graph a certain part of it, but this is just showing you a little bit of it. Okay, so on yours like doesn't have the negative part on it, that's fine. It goes from 0 to 2 pi, so just draw from 0 to 2 pi right here on your graph. And your next graphs, I left graphed for you on here. It's just kind of showing you if I want to do y equals 2 sine x, well, now I'm multiplying by a 2 on the outside. So that means I have multiplied every y value by 2 on our graph, which is stretching our graph by a vertical factor of 2. We looked at that before. So if you look at our graphs down here, the blue graph is the original graph. So the red graph is my y equals 2 sine x. I multiply everything by 2, so notice it stretches my graph up vertically. If I'm graphing y equals 1/2 sine x, we start with the graph of y equals sine x, and we're multiplying this time by 1/2. So then you can see on here that it is shrinking the graph vertically if I'm multiplying by a number less than 1. So you can see the orange curve in here will represent what that would look like. Nothing you have to graph on those. Okay, so in general, when we're looking at some functions, y equals a sine x and y equals a cosine x, the number a, which is the absolute value of a, is called our amplitude. That's the largest value these functions attain. So that's how high, how tall it goes on the y-axis, and the negative would be how low it goes on that axis. So if I look at an example, if I want to find the amplitude of y equals -3 cosine x and sketch its graph. Well, our amplitude, if we want to find our amplitude, it's just the absolute value of this number here. So our amplitude is the absolute value of -3, so it's just 3. So that means our graph is going to go up to +3 and down to -3 since cosine instead of 1 and -1. So you could plug this into your calculator again and look to see what it looks like. That means that I need to multiply this -3 out front. Means I multiply my y values by -3. So then if you do that with your graph, where's my graph? There it is. So our first one is the blue one. Since it's a negative, that means it's reflecting, right? So instead of starting right here at 1, I'm multiplying by -3. I move down here. The zeros would stay. Instead of 1, -1, I multiply by -3. I'm up here at 3. So it flipped it over the x-axis also. Okay, so now we're going to add a little more of our transformation. So if I have what we did before, this was just x inside. Now I'm adding this kx inside. So when that happens, my amplitude is still the absolute value of this number in front, but now we have to find the period. The normal period's 2 pi, but it might change. We might change that by transforming it. So our period is going to be what we call 2 pi over k. So you're going to take 2 pi and divide by whatever this number is in front of the x to get the new period of our graph. So an appropriate viewing window when you want to graph it, a complete period, you always want to graph at least one complete period, is 0 to 2 pi over k. Okay, if it's just x like what we were graphing before, that just means it's 0 to 2 pi like our original graphs that we had. So to see how this affects something, whoops, missed something here. Oh, to see how it affects it, we're going to graph y equals sine of 2x. Okay, so this is your next little example, y equals sine of 2x. So we need to find our period here. So our period is going to be 2 pi over k like we just had. So 2 pi, our k is 2. So our period is pi. Okay, that simply means that we, instead of going out to 2 pi, we are stopping all of our graph that we graphed before will be done with pi. So when we look at this, we know our period is 2 pi, 0 to pi completes one rotation. Okay, so we have y equals sine 2x. You can always put them in your calculator to kind of help you. You can see that we have our function, instead of this loop going up and down and then back again to 2 pi, it stops at pi and it completes all of its rotation in one. So we've shrunk that down horizontally this time by multiplying on the inside. So this means you multiply the x value by 2. Okay, so that helps you get the graph. So with this, we can see that the graph shrinks horizontally if k is bigger than 1, and it stretches if k is less than 1. Whenever we're looking, it's the same for sine and cosine. Here's just some comparisons that you can see what happens as our k changes. So we'd have our original function is our blue one. Sorry, our original function is the black one right here. This is our original function right here, just goes from 0 to 2 pi. So then if I do sine 2x as my red, so 2x means that I do all that complete rotation to pi. 1/2 is our blue function. Notice it's spread it out to 4 pi because this period right here would be 2 pi divided by 1/2, which is 4 pi, so it completes it. And then our sine 1/3 x goes all the way out to our 6 pi. So that's just some examples that's on there. It wasn't in your notes, but just kind of showing you what's happening. So here we have we want to find the amplitude and the period and then sketch the graph. So if we look at part A right here, I have y equals 4 cosine x. Okay, well our amplitude is the number in front, so our amplitude is 4. Our period, okay, there is not a number in front of the x. When there's not a number in front of it, our period is simply 2 pi. Oh, just kidding, I didn't write this right. Oh, scratch that. We have 4, 3, there should be a 3 here. So my period, make it match yours since I wrote it wrong, is 2 pi over k. So that's 2 pi. In this case, our k is the number in front right here is 3. So my period is 2 pi over 3. So if you're asked for your amplitude and your period, which you will be, you can find those. Again, you can let your calculator help you graph it, or just know you have to multiply your x by 3, your y's by 4 in your original cosine graph. Whoops, and your graph would look something like this. Okay, so keep that in mind. You can sketch your little graph on there, plug it into your calculator, see if you can see a resemblance. What if I have y equals -2 sine 1/2 x? Well, our amplitude is the positive of what's out here, so our amplitude is 2. It's the absolute value of -2. Our period is 2 pi divided by 1/2, which is 4 pi. Okay, you will be asked and need to be able to find these. And then if we were to graph it, this time it goes out to 4 pi with our one complete rotation. You only have to graph from 0 to 4 pi. The rest just shows you it continues on. Okay, so now we also are going to shift our sine and cosine curves, which means we're going to move them left or right when we're doing things. So now I'm adding more to our graph. Notice k has to be bigger than 0, because if k is 0, then everything is 0 in there. So when we have that, our amplitude is A. You need to know that. You need to know our amplitude is A. Our period, like we just looked at, 2 pi over k. What I'm adding to it is a horizontal shift of B right here. Okay. As a reminder, if our B, it's kind of, they do it different in here than when we think about it. If our B is greater than 0, it moves right. If it's less than 0, it moves left. But I don't like the way they necessarily do this. If you want to think about how we did it before, if you have x plus, notice up here it's always minus, so if it's x plus b like this, okay, that means that it's moving right. And if you have the x, nope, joking, that means it's moving left, it's the opposite. If it's minus, that means it's moving right. More than just think, what they will do is they'll rewrite things as x minus a negative b. And that's where they're getting that it moves left if it's negative, because they make it a negative and a negative, which is really the positive right here. So you can think about it either way. When you are graphing it, one complete rotation would be start at B and go to B plus whatever your period is. Okay, so let's look at some examples. Most of your graphing is going to be multiple choice type questions on your assignment, and we'll deal with graphing some of them later, actually by hand. So here I want to find our amplitude, period, our horizontal shift of y equals, and then graph it, one complete period of 3 sine 2 of x minus pi over 4. Okay, So if we look at this, our amplitude, remember, is the number out front. So our amplitude is 3. It has to be positive. Our period is 2 pi over k. K is this number out in front. So this is 2 pi over 2. So our period is pi. And then our horizontal shift, okay, sometimes you're going to see this called phase shift, and we'll talk about it more next time. Horizontal shift / phase shift is what's going in here. So in this case, it's pi over 4. And since it is negative in here, that means it's pi over 4. It's positive, which means it's pi over 4 to the right. If you just write positive pi over 4, that actually means it's moving to the right because this number is a positive value. Okay, so we have our solution. Then you could graph this. Remember to graph it. You start with what b is. Our b is pi over 4. Then you do pi over 4 plus pi, which is 5 pi over 4. So I start at pi over 4. I end at 5 pi over 4. You know, halfway in between at 3 pi over 4 at 0. And it will complete one of our rotations. Okay, so let's do one more of these, and we are going to be done for the day on our notes. So again, we're finding the amplitude, period, horizontal shift. So our period, remember the number in front, so our amplitude, our amplitude, okay, is going to be 3/4. Our period, well, normally it's that number that's out front right here, right? Well, there's not, so we need to rewrite this in our general form. Remember, our form is A cosine K x minus B. That means we have to figure out what K is going to be. So X just has to be a number without, or a variable without anything in front of it. So I have to take this first part right here, and I need to factor out whatever number is in front of that. So the 3/4 is going to stay. Cosine, I'm going to factor this 2 out. So I factor it out here, I'm left with an x. If I factor the 2 out here, then I'm left with pi over 3. The 2 on top goes away. So now I know what my k is right here. So sometimes you're going to have to rewrite your function. So now my period is 2 pi over 2, which is pi. And my horizontal shift, which we call b, also called a phase shift. You'll hear that word a lot more in next class. Okay, so over here we're plus pi over 3. So you can say pi over 3 to the left, or you could just tell me it's negative pi over 3 because that means it's moving to the left because it's a negative number. And then you could plug that in to graph it. I recommend plugging it in. Make sure you can get the graph right here. Where's my graph? Here we go. Here we go. So it starts on our window. We're going from negative pi over 3, ends at 2 pi over 3. So negative pi over 3 is where it has to start because it has to start on whatever your b is. And I moved left negative pi over 3, ends at 2 pi over 3. Find halfway in between, which is pi over 6 in this case. That's where it goes down to 0. And then you could sketch in your graph. When you're sketching it, take your original graph, do these main points like where it's at, was at 1, where it was at 0, and then transform it that way. Okay, the rest of your notes you can mark off. We actually are not going to do those. We're going to do something a little different next time. So the graphing part of it, go ahead and just mark all of that off. And then you will have an assignment on WebAssign over this. If you have questions, let me know, and we are going to talk about it more next class also.